All right, let's be honest. When was the last time you really thought about the box that just arrived at your door? Probably never, right? We see them, we open them, we recycle them. But that simple cardboard box, it's actually a minor miracle of engineering. Today, we're going to unbox the surprising science behind packaging. To kick things off, let's start with a simple question. I know. It sounds like the beginning of a really weird joke. You've got this delicate fruit, a super fragile dessert, and then these heavy, clunky industrial parts. I mean, on the surface, they have absolutely nothing in common, but they all share one critical vulnerability. Yep, every single one of them has to get from point A to point B, totally safe and sound. And for a big shipment of mangoes, that home is a specially designed corrugated mango box, just like this one, from a manufacturer called Boxfool. Now for a beautiful birthday cake, the needs are completely different, aren't they? It's way less about stacking strength and so much more about presentation. You gotta protect that delicate frosting. So of course it gets its own unique home. And what about those heavy machine parts? Well, they need a tough, rugged, no-frills container that's built for pure protection and durability. And here's the key. You can't just swap these boxes around. Each one is a very specific solution to a very specific problem. So, how exactly are they different? Well, it all comes down to their anatomy. We're about to pop the hood and see that what we all just call cardboard is actually a pretty sophisticated composite material. The official name for it is corrugated board. And here's the basic recipe. You take 2 flat sheets of paper, those are the liners, and you sandwich a wavy arched layer of paper right in the middle. And that wavy part, that's the secret sauce. Think of it like an I-beam that you'd see in construction. The liners on the top and bottom give it the flat surfaces, but the flute, that wavy bit in the middle, is what creates all the space and structural rigidity. It stands up to pressure, it absorbs impacts, and together, these 3 simple layers create something that's incredibly strong, but also super lightweight.
And this shows you a really simple but brilliant way to ramp up that strength. A single wall box, that's your standard, everyday container. But if you need to stack heavy stuff or protect something really valuable, you just add another layer of flute and another liner, and bam, you've created a double wall board. It's like adding another I-beam, which just massively increases its resistance to being crushed.
So let's zoom in on the most important part here. It's not really the thickness of the paper that matters most. It's the size and the shape of these waves, the flute. This is where the real engineering decisions happen. And believe it or not all flutes are created equal. They're actually given letter designations. So an A flute has these wide, tall arches, which makes it amazing for cushioning fragile items. On the other hand, an E or F flute has these tiny, tight waves. It doesn't cushion as well, but it gives you a beautiful, smooth surface that's perfect for printing high-quality graphics on a retail box. You know, what's so cool about this is how clearly it connects the engineering to the actual use. You don't just pick a flute at random. Are you shipping fragile glassware? You absolutely need the cushioning of an A flute. Are you building a giant pallet of boxes for a warehouse? You need the stacking strength of the C flute. That's the real workhorse of the shipping world. Need a pretty box to sit on a shelf in a store? That's a job for the E flute. Okay, so now that we've got the theory down, let's see how it actually applies in the real world. We can take all this technical know-how and connect it right back to those examples we started with. We can finally answer our first question, but with a lot more detail now. It's not just that the stuff inside is different, it's that their journeys and their needs are totally different, which of course requires totally different engineering. And here it is, the payoff. A mango box needs to be stacked super high on a pallet without crushing the fruit at the bottom. So it's likely a strong double wall with a C flute. A cake box is all about looking good, so a thin E flute with a great print surface is perfect. And for a can of oil, you might be worried about it getting punctured, which is where the tighter waves of a B flute really shine. See, every box is a choice. And here's one last little detail that's surprisingly important. When you measure a box, that sequence, length times width times height, it's not random. The length and width always define the opening of the box. So getting that sequence right is absolutely critical for the manufacturer to build the box you're actually expecting. Okay, we have covered a lot of ground, from fruit to flutes, so let's wrap this all up by boxing up the most important takeaways from all this. So the number one thing to remember is this. A box's strength comes from that wavy flute inside.
The type of flute tells you how it's strong. Is it for cushioning or for stacking? Double wall is your secret code for heavy-duty applications. And maybe most importantly, you always start with the product and its journey to figure out the right design. It's all about function.
I think this just nails it. We tend to dismiss the box as disposable, just a container. But in reality, it's a carefully calculated, incredibly efficient, and brilliantly engineered solution to a really basic challenge: how to move things through the world safely. So the next time a package shows up, before you tear it open, just take a second. Look at the edge. Can you see the little waves of the flute? Can you tell if it's a single or double wall? Because now you can see it not just as a box, but as a piece of intentional design. What story is it telling you?